Welcome back, children. We can do more problems related to increasing and decreasing functions. So the first question, show that y is equal to log 1 plus x minus 2x by 2 plus x, where x is greater than minus 1, is an increasing function of x throughout its domain. So we have to prove the given function is an increasing function. What do you mean by increasing function? What we have to prove? We have to prove dy by dx is greater than or equal to 0. If it is greater than only, then it is strictly increasing. If it is greater than or equal to 0, then the function y is an increasing function. Domain is given, x is greater than minus 1. Then look, the first term, the first function is log 1 plus x. Log function is defined only for positive numbers. That's why it is the domain is x is greater than minus 1. If x is minus 1, the value log 0, it is not defined. So x is greater than minus 1, that is the domain of the function. Now we have to prove that this function is an increasing function. So y is equal to log 1 plus x minus 2x by 2 plus x. Now find dy by dx, that is derivative of y with respect to x. So here we have two terms. So we can do separately. First take log 1 plus x. What is the derivative of log 1 plus x? It is 1 by 1 plus x. Then by chain rule we have to find the derivative of the bracket, that is 1 plus x. Its derivative is 1. So only 1 by 1 plus x. Minus, this is 2x by 2 plus x. So we have to use quotient rule, d by dx of u by v. That rule we have to apply. So put a bracket, denominator into, what is the quotient rule? Denominator into derivative of numerator. Numerator is 2x. What is the derivative of 2x? 2. Minus numerator into derivative of denominator. Denominator is 2 plus x. What is the derivative of 2? 2 is a constant, its derivative is 0 and x derivative is 1. Then by 2 plus x whole square, denominator square. Now we have to simplify. So that's equal to 1 by 1 plus x minus 2 plus x whole square, that's in the denominator. 2 into 2, 4. 4 plus 2x minus 2x. So 2x cancel. Again we can simplify. The LCM is 1 plus x into 2 plus x whole square. Then the numerator is 1 into 2 plus x whole square is 2 plus x whole square minus 4 into 1 plus x. Then again simplify that. Expand. A square plus 2ab plus b square minus 4 minus 4x by 1 plus x into 2 plus x whole square. 4x cancel, 4 cancel. So it is x square by 1 plus x into 2 plus x whole square. And this is dy by dx. We have to prove y is an increasing function. So this should be greater than or equal to 0, that we have to prove. Is this right hand side greater than or equal to 0? Given that x is greater than minus 1. So what about this 1 plus x? Add 1 on both sides. 1 plus x is greater than 1 minus 1. That is 1 plus x is greater than 0. So this first factor, that is greater than 0. What about 2 plus x whole square? 2 plus x whole square, that is always greater than 0. Since x value is greater than minus 1. So denominator is greater than 0. Now look at the numerator, that is x square. That is square. Square of a number is always positive. but it can be 0 also. The domain is greater than -1. So, 0 is in the domain. So, when we substitute x is equal to 0, this whole thing that becomes 0. So, the right hand side 2 plus x whole square greater than 0, 1 plus x greater than 0, and x square is greater than or equal to 0. That only we can say. So, dy by dx is greater than or equal to 0 for x belongs to greater than, what is the domain of the function, -1 to infinity open interval. So, we can conclude dy by dx greater than or equal to 0 for each x belongs to -1 to infinity. Hence, what we can conclude? Hence, y is an increasing function. Y is an increasing function. So, we proved. Now, the second one, find the value of x for which y is equal to x into x minus 2 the whole square is an increasing function. Find the values of x. We have to find x. So, it is an increasing function, that is given. No, we find the value of x for which this function is an increasing function. So, we have to find x. So, first we have to find the derivative. So, before that we can open this x square minus 2x whole square. Now, what is the derivative with respect to x? So, a term square, its derivative is 2 times x square minus 2x. Then, according to the chain rule, we have to find the derivative of the bracket x square minus 2x. So, that is equal to 2 into x square minus 2x into, what is the derivative of x square minus 2x? That is 2x minus 2. Since we have to find the values of x maximum, you have to simplify this. 2, x is common, x into x minus 2, here 2 is common, x minus 1. Or we can write 4 times x into x minus 1 into x minus 2. That is dy by dx. Then, in the last class we have discussed how to find the intervals in which the function is increasing or decreasing. For that we have to substitute, we have to put dy by dx is equal to 0. So, here also we have to find the value of x, so put dy by dx is equal to 0, which implies each bracket, each factor equal to 0. 4 is a number that is not 0, so which is 0? First I write the dot full expression is equal to 0. Then next step, put each one equal to 0. 4 is not 0, so x can be 0 or x minus 1 can be 0 or x minus 2 can be 0. Which implies x is 0, x is 1 and x is 2. Now, find the intervals. So, minus infinity to infinity, that function, look at the function, every real number we can substitute for x. So, domain is set of real numbers. So, draw the number line, mark all these points 1 and 2. So, intervals, how many intervals are there? Interval, then sign of f dash x, then nature of f. 3 column. First interval is minus infinity 0, then 0 to 1, then 1 to 2, then next one 2 to infinity. Then minus infinity 0, take a point from that interval, I can take minus 1, okay. So, when x is minus 1, what is f dash x? Substitute in f dash x, f dash x or dy by dx. Here we have dy by dx, not f dash x. So write dy by dx is equal to, when x is minus 1, here you have to substitute. So 4 into minus 1 into the next number, minus 1 is minus 2, then minus 1 minus 2, that is minus 3. So 3 negatives are there. So the answer is a negative number, is less than 0. So minus infinity 0 means sign of f dash x is negative. So what is nature of f? F is strictly decreasing. It is strictly decreasing. Now the second interval 0 to 1. 0 to 1 we can give 0.5 or 1 by 2. When x is equal to 1 by 2 or 0.5. dy by dx is equal to 4 into 0.5 is positive, 0.5 minus 1 that is negative, second bracket 0.5 minus 2 that is also negative. So dy by dx is greater than 0. That is f is strictly increasing. Now the third interval 1 to 2. So here it is 0.5. 1 to 2 I can take 1.5. So when x is 1.5, what is dy by dx? 4 into 1.5 that is positive, 1.5 minus 1 that is positive, 1.5 minus 2 is negative. So total it is negative. So f is strictly decreasing. Now the last interval 2 to infinity, we can take 3. So when x is 3, 4 into 3 positive, 3 minus 1 is positive, 3 minus 2 is positive. So total dy by dx is positive, greater than 0. That is strictly increasing. So what is the question? Question is, find the value of x for which the function is an increasing function, not strictly it is an increasing function. So that only you have to write. So in which all intervals functions increasing? In 0, 1 and 2 to infinity. So therefore conclusion, f is increasing on, increasing means you have to put closed interval. So increasing on closed interval 0, 1, then we put union. If more than one interval you can put union symbol, union, the next interval is 2 to infinity. So 2 is closed, infinity is open. When we put x 2, 0 or 1, when we put x 0 or x 1 or x 2, the dy by dx equal to 0. Increasing means the condition is derivative greater than or equal to 0. So f is increasing on this interval. So these are the values of x. Now the next question. Prove that the function f given by f of x is x square minus x plus 1 is neither strictly increasing nor strictly decreasing on minus 1, 1. So f of x square minus x plus 1. The first step is find the derivative, 2x minus 1. Then we put this equal to 0, which implies 2x minus 1 is 0, that's equal to x is equal to 1 by 2. Then interval, here it is given minus 1 to 1. Usually we write minus infinity to infinity, then mark 1 by 2. This is a polynomial function, domain is set of real numbers. But here it is mentioned minus 1 to 1, there only you have to check. So I am drawing the number line starting with the minus 1, then 1. Mark the point 1 by 2. Then intervals. Which are the two intervals? Interval sign of f dash x and nature of f. So first interval -1 to half, then half to 1. -1 to half, we can take 0. So when x is equal to 0, what about f dash x? F dash x is negative. When x is 0, f dash x is negative. Negative means strictly decreasing. Strictly decreasing. Now from the interval half to 1. Half to 1 I can take 3 by 4. 3 by 4 it means 0.75. So when x is equal to 3 by 4, what is f dash x? Positive or negative? That is 2 into 3 by 4 minus 1. That is 6 minus 4 by 4. It's a positive quantity. So greater than 0, that is strictly increasing. So -1 to half function is strictly decreasing, and half to 1 it is strictly increasing. So what about the interval -1 to 1? The whole interval -1 to 1, we can say the function is neither increasing nor decreasing. Understood? The half portion it is strictly increasing, half portion strictly decreasing. So when we consider the whole interval, we can say that f is neither strictly increasing nor strictly decreasing. Hence, f is neither strictly increasing nor strictly decreasing on which interval? Open interval -1 to 1. The next question, prove that y is equal to 4 sin theta by 2 plus cos theta minus theta is an increasing function of theta in closed interval 0 to pi by 2. We have to prove it. Y is given, y is equal to 4 sin theta by 2 plus cos theta minus theta. Sorry. First step, we have to find dy by, it is an increasing function of theta. So differentiate y with respect to theta, the right hand side in terms of theta. So dy by d theta. Here it is quotient rule we have to apply. Rational form. So the quotient rule is denominator into derivative of numerator. Numerator is 4 sin theta. Derivative is 4 cos theta. Minus numerator into derivative of denominator. Denominator 2, derivative 0, cos theta is minus sin theta. Then divided by denominator square. Then we have on theta. So minus, what is the derivative of theta with respect to theta? That is 1. Now simplify. 2 into 4 cos theta is 8 cos theta plus 4 cos square theta plus 4 sin square theta by 2 plus cos theta whole square. Denominator no need to expand. Just keep as itself. Minus 1. So that's equal to 4 cos square theta and 4 sin square theta becomes 4. 8 cos theta plus 4 minus 1. Here 2 plus cos theta whole square. Again we can simplify taking LCM. So 2 plus cos theta whole square. Numerator is 8 cos theta plus 1 plus 4 minus 2 plus cos theta whole square. Then expand 2 plus cos theta whole square in the numerator. So 8 cos theta plus 4 minus bracket 4 plus 4 cos theta plus cos square theta by 2 plus cos theta whole square. 4 cancel. 8 cos theta minus 4 cos theta is 4 cos theta minus cos square theta by 2 plus cos theta whole square. Or we can write the left hand side is dy by d theta. Cos theta is common. Cos theta into 4 minus cos theta by 2 plus cos theta whole square. Now, what is the question? Prove that this function is an increasing function. Increasing means we have to prove dy by d theta greater than or equal to 0. And the interval is given 0 to pi by 2. Closed interval 0 to pi by 2. So, if theta belongs to 0 to pi by 2, what about cos theta? 0 to pi by 2 means it is in the first quadrant. Cos theta value is positive. Cos 0 is 1 and cos 90 is 0. So, look here. Denominator is 2 plus cos theta whole square. Denominator is always a positive. It is square. Then this cos theta value, that cos theta is from 1 to 0. Positive, and it gives the value 0 at pi by 2. Then 4 minus cos theta. It cannot be negative since cos theta value is 1 to 0. So 4 minus 1 to 0, that range is always positive. So we can write this dy by d theta. It is positive as well as 0. When this value is 0, when theta is equal to pi by 2. So, if theta belongs to 0 to pi by 2, this dy by d theta is always greater than or equal to 0. That means y is an increasing function, isn't it? Y is an increasing function. That is the definition of increasing function. Increasing function of theta. So, we proved. Now, the fifth one, let I be any interval disjoint from minus 1, 1. That is, I is not this minus 1, 1. I is any interval other than this. Prove that the function f given by f of x is x plus 1 by x is strictly increasing on I. So, I is any interval other than minus 1, 1. In that this function is strictly increasing. So, f of x is x plus 1 by x, f dash x is derivative of x is 1, derivative of 1 by x is minus 1 by x square. Then in the next step, we write f dash x is equal to 0, which implies 1 minus 1 by x square equal to 0. Or taking LCM, x square minus 1 by x square equal to 0. That implies numerator is 0. If numerator is 0, the total quantity is 0. That implies, which implies x square minus 1 is 0. So, what is the value of x? X is equal to plus or minus 1. Okay. Now, we draw the number line, minus infinity, infinity. 0 is not included. If it is 0, the function is not defined. But here we have minus 1, which is the interval. The points are minus 1 and 1. And we have to consider the interval minus infinity, minus 1 and 1 to infinity. And we have to prove that the function is strictly increasing them. So, I am writing here interval sine of f dash x and nature of f. So, minus infinity minus 1 and 1 to infinity. What about the function? Minus infinity minus 1, we can take minus 2. When x is minus 2, what is the value of this f dash x? Minus 2 means minus 2 square is positive number. So 1 by 4. Is that is positive or negative? Or you can, if it is difficult to substitute there, you can substitute here. This f dash x is same as x square minus 1 by x square. Okay, here f dash x is equal to x square minus 1 by x square. So if x is equal to minus 2, what about f dash x? Minus 2 square is 4, 4 minus 1 is positive, positive by positive is positive. Then from the next interval, from 1 to infinity, we can take 2. So when x is equal to 2, what about f dash x? Here also 4 minus 1 by 4, that is positive. So minus infinity to minus 1 there positive, 1 to infinity also positive, that is function f is strictly increasing. Here also strictly increasing. Then what about this interval minus 1 to 1? If I take minus 1 to 1, take a point from here, you can take 0, substitute 0, 0 minus 1 by 0. 0 we can't give, sorry. Any other value you can give? Any other value, that is 0.5 you can give, 0.5 minus 1, that is negative number by 0.5 square. So here the function is negative. But what we have to prove? Look at the question, let I be any interval disjoint from minus 1, 1. So don't consider this minus 1, 1. The other intervals, that is other intervals means minus infinity to minus 1 and 1 to infinity. There the function is strictly increasing, isn't it? In these two intervals function is strictly increasing. So we proved. So we can write the conclusion. Hence f is strictly increasing on minus infinity, minus 1, union 1 to infinity. That is f is strictly increasing on the interval disjoint from minus 1 to 1. If we give x is equal to 1, the function is 0. Okay. Then if we give x is equal to minus 1, then also 0. So if we substitute these 2 points, n points, we get 0. So strictly means you have to put open interval. So in these 2 intervals the function is strictly increasing, and this interval it is decreasing. Okay. So we verify that.